All right, friends, now is the time where we get to bust out our sister calculator. Because today we get to look at our word problems. Woohoo! Now, if you're in physics, you're gonna be like, holler, I already know all this. So great, you should be a professional and tutor all your other friends in this class. So we are gonna be doing those problems where it's like, you're standing on a cliff and you throw a ball off the cliff at this velocity, blah, 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 blah. How high does it go? How far does it go? You get it. But we're gonna be doing this as parametric equations. So I'm gonna have the equation for the x distance and the y distance. So that's what this guy is here. Now, I'm not sure what equations y'all use in physics, but for this, we're gonna be using 16t squared. We get the 16 because we use gravity in feet per second for these problems. You probably used 9.8 in physics because they're the realist and use meters, but not us, we're doing feet. So let's just get started. Number one, we're gonna go straight forward. Let's just practice plugging in these numbers and getting an equation and using our graph. So we're gonna find the maximum height and distance if this stuff's going on. So I'm gonna write my x equation and my y equation, plugging in these values. So initial velocity is 88. Cosine, my angle is 60 degrees. And then my time is just t. This will be in terms of t because again, these are parametric equations. So let's do y. There is no initial height, so I'll just leave that at 0. You don't have to write the 0, obviously. Initial velocity is still 88, but this time we're doing sine. There's a t here, minus 16t squared. Okay, now when I go in my calculator and I go to type in an equation to my graph, my equation is in f of x. So my variable needs to be x. Right now it's t. So I'm gonna do like what we did yesterday and convert this equation into t equals to then plug in. So x, all of this is multiplied, so it's gonna be x just divided by all this. And then to plug it into my y equation, I have two places where t is gonna be both of those things. So when I go to graph, instead of typing in t, I'm typing in x over 88 cosine 60. Okay, your calculator might be in radians. This is 60 degrees. So confirm that your settings are in fact in degrees. I don't know why mine doesn't say make default, but make sure you click make default. Okay, so I'm gonna type in my y equation. I don't need to type in the 0, so I'm not. 88 sine 60. And now instead of saying t, I'm gonna type in x over 88 cosine 60 minus 16. And then this t value, I'm gonna put in parentheses because I have to square it. X over 88 cosine 60, arrow out of the parentheses so you can square it. Now your 16 isn't squared, just your t. Push enter so you can graph it, and then we're gonna have to zoom out. I'm gonna zoom out until I see this whole parabola. Okay, and there she is. So something was hit off the ground and then landed on the ground. I need to find the maximum height and max distance. Okay, to find the maximum height, I'm going to analyze my graph. Maximum, let's figure out where this maximum is. So I have two values, an x and a y value. If I'm doing max height, that's the y value. So 90.75. I'm measuring this in feet. Max distance is where it lands on the ground. So that's this intersection of the x-axis here. So menu, analyze graph, and x-intercept is also called a 0. So let's figure out where this 0 is. So I'm looking for the distance, so the x distance, that's the x value, 209.58 feet. We did it. Let's do another one now with like real words. Okay, a baseball leaves a bat with an initial velocity of 152 feet per second. So let's jot that down. We'll need to know that. An angle of elevation of 20 degrees. So theta is 20. The ball is 3 feet above the ground when it's hit. That's our initial height. And a 20-foot fence is 400 feet away from home plate. So we have this fence, and the coordinate of the fence, it's 400 feet away and 20 feet high. I bet we use that later. First, let's write our two parametric equations, so the x equals and the y equals that were given at the top of this page. Initial velocity, cosine angle times t. Initial height plus initial velocity sine of your angle times t minus 16 t squared. But we need to figure out what t is. X over 152 cosine 20 that we're now going to plug in to here and here. Before I even graph it, I'm going to sketch it because I know what it looks like. So we're starting 3 feet off the ground. We have the baseball. It's going to be hit, and then it's going to land. Now, on a real graph, like in real life, this baseball is going to go below the ground. But obviously on our graph in our calculator, it's going to keep going. But we don't care about her. So we sketch the graph. Now let's go ahead and graph it, because the next question is, will the ball go over the fence? Because we have 3 scenarios that could happen. Scenario number 1. Here's our fence. The ball could go over the fence. Cool. Second scenario, our ball could hit the ground before the fence. Sheesh. Third scenario, our ball could hit the fence. So we need to graph this to figure out what our ball is doing at these different locations. So let me clear out my graph. And I'm going to graph this y equation, but plug in, remember, our t. So 3 plus sine of 20 times x over 152 cosine 20 minus 16. Use parentheses on this one because you're going to have to square it. Okay, let's zoom on out. Okay, so at this point I can see the highest and where it hits the ground. So I don't care about max height or max distance. All I care about is, will this ball go over the fence? Well, my fence, remember, is at 400 feet away and it's 20 feet high. So I am going to graph trace at a distance of 400 to see what my graph is doing at 400. So menu, trace, graph trace, type in 400. And so at 400, the ball is this high off the ground. Well, how tall is the fence? It's only 20 feet. So this means the ball is over the fence. So my ball went over the fence. So will the ball go over the fence? Yeah. Because at 400 feet, the ball is, our calculator said, about 23.1. Oops. 0.1 feet high. Woohoo! Let's do one more together. Okay. A ball hit off of a 7-iron in golf. 7-iron, a lot of people want to be like, where do I put the 7 in my equation? Nowhere. 7-iron's just the type of golf club. It leaves the club at 110 feet per second. That's their initial velocity. The angle is 35. Okay, let's write down our given information. So my initial height, 0. Golf balls hit off the ground. Initial velocity, 110. Theta, 35 degrees. Do I have anything else? No. Let's write our equations. X equals and Y equals. So 110 cosine 35t, 110 sine 35t minus 16t squared. But I need to plug something in for these t's, so let's convert. T equals x divided by 110 cosine 35, and plug these bad boys in here. I'm gonna go ahead and do that because I can already see the next questions and asking me max distance. Sure. Clear your graph, and let's re-sister graph. 10 sine 35 times x over cosine 35 minus 16. Use parentheses. X over 110 cosine 35. Get out before you square it. Zoom out. If you're having issues with the calculator, please ask your neighbor, because come time for the quizzes and tests, it's going to be too late. So if you're typing in these equations, but you're getting something different from me, find somebody who is getting the same answer and ask them what to do. You need to figure out the calculator. Okay, max distance. So that's this far right side. Menu analyze, that's an x-intercept, which is a 0. Left side, right side. So that's 355.32. We are measured in feet. Maximum height, so that's the maximum. Remember, height is y value. It's a y distance, so pick the y value. That's 62.2, we'll say. Don't forget your units. Okay, you have a 4-foot pole standing in the line of the direction of the golf ball 320 feet down the range. So the pole is 320 feet away and it's 4 feet high. Will the ball go over the pole? So this is similar to the baseball hitting the fence. So I'm going to graph trace that 320 to see what our golf ball is doing there. And at 320, my golf ball is a height of 22.27. Is that going to go over a 4-foot pole? Yes. The ball is at a height of 22.27 feet. So of course it'll go over a 4-foot pole. Wow. Okay, and just like that, we're done with this packet. I want you to do number 4 for homework tonight. My answers are all on Schoology, so please try to do this one yourself before you go get the answer off Schoology. Make sure you're correct. And the next page is just more practice, which again will be on Schoology. Please make sure you're studying up. Review, review, review. You'll have a test very soon, your first test. Oh my gosh, without me, good luck and bye.